All right. My name is Andrew Wolka. I'm a principal director at Booz Allen Hamilton. I work within our chief technology office, and my focus is NextG. Today, I'm going to be talking about the emission control, or MCON rApp, that we developed in collaboration with Ericsson. So first, I'll go through a quick background on Booz Allen. Booz Allen is an advanced technology company delivering outcomes with speed for America's most critical defense, civil, and national security priorities. You can see the list of our clients here. Again, focus on public sector with defense, intelligence, civil, and we also have a global commercial business. We have a little over 34,000 employees, and we are the #1 provider of cybersecurity and AI to the federal government. Related to 5G, we're currently deploying private 5G networks for our clients. We're also building applications on top of those networks to take advantage of the connectivity, the low latency and high throughput that 5G provides, and also securing those networks. And so today I'm going to talk about the MCON rApp, and we developed a video that gives an overview of the app. So I'll play that first.
In the modern battlefield, military forces operate under various emission control, or MCON levels. Radiation requirements shift depending on operational needs. During combat or covert operations, more restrictive MCON levels minimize the risk of detection by adversaries' electronic surveillance. In critical situations, military units may enforce radio silence to avoid detection. Restricting non-essential radio transmissions reduces the likelihood of interception or location by adversary sensors, but achieving this flexibility can be challenging. Commercial 5G systems do not have specific MCON levels built in, which means skilled operators must log in to radio access network, or RAN systems, and make time-consuming manual power adjustments to meet MCON requirements. To help agencies address this challenge, Booz Allen, in collaboration with Ericsson, developed the MCON rApp. Based on provided input, the solution automates military MCON scenarios on 5G networks to minimize the risk of detection and interference from hostile forces, strengthening operational security and mission resilience.
Yes.
The MCON rApp operates on the RAN Intelligent Controller, RIC function of the Ericsson Intelligent Automation Platform, or EIAP, in a 5G network. Based on a change in MCON level, the rApp automates network configuration to required mission levels, reducing admin time and avoiding misconfiguration while making network changes. When you empower your mission with the MCON rApp, warfighters can avoid adversary tracking at target. As enemy forces approach a network coverage area, the change in MCON level initiates the rApp, enhancing your strategic advantage. And beyond defense applications, this foundational functionality can be efficiently applied to create new domain-specific rApps for a variety of industry verticals. Learn more at boozallen.com/5G.
Okay, so that provides you a quick overview of the use case that we developed with Ericsson. So let's start a little bit on the platform that we built this on. So Ericsson's Intelligent Automation Platform. It's an open and multi-technology platform for automation and RAN performance. And you can see in the diagram here our rApp. In the middle, we're interfacing with Ericsson's R1 interface to connect to EIAP. And then our rApp is running in the non-real-time RIC and interfacing with the RAN components. So a few of the key values of EIAP: again, consolidation with multi-technology and multi-vendor, reducing operational complexity and cost. This is where we see big benefits in achieving, accelerating the outcomes for our clients, and then empowering innovations with openness. Again, enabling third-party apps to connect to EIAP, and then also run on third-party platforms. All right, so this gets into the background on the MCON rApp. Heard a little bit of this in the video, but what is the rApp? So the rApp automates military emission control scenarios on public sector 5G networks in order to maintain mission success by minimizing the risk of detection and interference from hostile forces. So essentially the goal is to better control our RF footprint in different operational scenarios. And so why are we doing that? So military forces implement various MCON levels throughout their operations. Those could go all the way up to radio surveillance, where we're not emitting any RF, and the goal being to avoid detection. And so in those scenarios, how would they do it today, right? You've got a private 5G network operating. How do you control it for those different MCON levels? Today, that would take a highly skilled operator who could log into the network, make configuration changes to control the RAN properly. And today, in a lot of private 5G networks and in defense applications, you don't have those skilled operators like you would on an MNO side. So our app is really implementing automation to enable those changes in the radio transmission. So we developed that app, onboarded it onto Ericsson's EIAP platform, and then the app enables recommended power changes and network configurations within the RU. So here's a quick architecture of the development of the R app. We built a front end. It's got a GUI that shows the different levels for the operator, and then a back end that interfaces with the EIAP and the different APIs. We deploy that app on a container within the non-real-time RIC. It interfaces with the APIs to make configuration changes on the 5G cells. All right, so now let's get into a demo of the app. So on the left-hand side is our GUI that we built for our R app. The right-hand side, this is a dashboard from Ericsson's Smart Energy Smart Site. There's two different views. One is power consumption, and the second is radiated power. And so the radio of interest here is this AIR6419. You can see right now this is at a full emission state. It's consuming 302 watts, and it's in an unlocked state. So we're at full emission and full radiation. This radio also has a channel bandwidth of 100 megahertz. And so our R app has a memory of the initial kind of full emission capabilities, so that as we move through different MCON states, we can always revert back to full emission. So we'll walk through a few of the different scenarios here. The first one we'll go to is zero emission. So you can see here the operator clicks zero emission, and you get a confirmation status within the R app. And then if we move over to the Ericsson network side, you can see this change to a locked state. So the cell went into cell lock, and there's no emissions out of that radio. Now we'll move to low emission. You can see here on low emission, we changed to the power radiated. And what we did was we changed the RF channel from 100 megahertz down to 40 megahertz. So you can see the change here, and we're at 320 watts of radiated power. Next, we'll go to the partial restore state. So again, you see success for partial restore, and you can see on power radiated, we changed from 40 megahertz. Again, we have the memory of the original full emission configuration. We expand that back to the 100 megahertz bandwidth, but we lower the power down to 32 watts. So that's the partial restore, and now we'll go to full restore. So this is a full restore state. You can see our power consumption is back at around 303 watts, and you can see unlocked, we're now back in full emissions. So that's a quick demo of the app. Again, we went through essentially different scenarios, but those can be customized based on the requirements of the mission or the operation. So again, just to summarize, Booz Allen, advanced technology company, delivering speed to outcomes for our clients. And we really see EIAP and this R app as a great example of us doing that, right? We're enabling our operators and our users to get to an outcome more quickly through this automation. So the R app providing a centralized solution for maintaining emissions control levels throughout different mission scenarios. We're reducing network configuration time, providing the means for implementing mission-specific operational policies.